Welcome to Phototransduction, brought to you by Vicious and Delicious. I'm your host, Nathan Heineman.
I'm Sarah Montgomery, and I will play retinol and the portrays receptor.
I'm Sarah Bullock, and I am opsin and the visual cortex.
I'm Spencer Pengaker. I play phosphodiesterase and the cation channels.
I'm Andrew Farmer, and I will be cyclic nucleotide-gated sodium channels and G protein.
I'm Stanley Burgess, and I'll play calcium leak channel and optic nerve.
I'm Kendall Negley, and I'll be a voltage-gated calcium channel and the thalamus.
And I'm Duvan Singnavong, and I'll be the cameraman. First, we'll be talking about phototransduction in the dark.
We'll begin with a rod in the dark. Since no light is striking the eye, retinol is in the cis conformation and remains attached to opsin. The alpha subunit of the G protein transducin remains attached and therefore does not activate phosphodiesterase. This allows cyclic GMP to bind to cyclic nucleotide-gated sodium channels, causing them to open, resulting in an influx of sodium. While this is occurring, potassium leak channels remain open, leading to an efflux of potassium. However, more sodium is flowing in than potassium is flowing out, and the net effect is the depolarization of the cell. This triggers voltage-gated calcium channels to open, resulting in an influx of calcium, which in turn triggers the release of glutamate into the synaptic cleft. Glutamate binds to metabotropic receptors on the membrane of the bipolar cell, causing a G protein's alpha subunit to close cation channels. This results in hyperpolarization of the bipolar cell and an inhibitory postsynaptic potential, so no neurotransmitter is released. Since the bipolar cell produces an inhibitory postsynaptic potential, the ganglion cell does not send action potentials to the visual cortex, and no visual processing occurs.
Now, we'll be talking about phototransduction in the light.
Now, when light strikes the rod, it causes retinol to change conformation from cis to trans, and it dissociates from opsin. This activates the G protein transducin, whose alpha subunit shifts over and activates phosphodiesterase. Phosphodiesterase degrades cyclic GMP. Without cyclic GMP, cyclic nucleotide-gated sodium channels close and sodium influx stops. Since potassium leak channels are always open and efflux of potassium continues, this results in hyperpolarization of the cell. This hyperpolarization prevents voltage-gated calcium channels from opening, and glutamate will no longer be released into the synaptic cleft. Since glutamate is no longer being released, it will not bind to the metabotropic receptors, and the G protein will not be activated. This allows cation channels to stay open and an influx of cations to occur. The resulting depolarization produces an excitatory postsynaptic potential. A neurotransmitter is released. This neurotransmitters bind to the ganglion cell, which is now more likely to produce an action potential. If an action potential is produced, it will pass down the optic nerve to the thalamus, which relays the signal to the visual cortex of the occipital lobe for processing.